All right, so this week we're going to continue the cultivation and development of our skill as 3D modelers. Okay, as you learned, or as I hope you learned last week, being a 3D modeler takes some comfort, it takes some experience, and it takes some mastery of some tools to get some really good results. Okay, this is not a fast, easy process. We're not making one model; we're actually making like 8,000 little models that are all interconnected. Okay. Today we're going to take a look at how we can continue that development by looking at some construction practices and some construction techniques. We're also going to look at Booleans today, which opens Pandora's box a little bit, but I think you're going to find that Booleans are pretty exciting nonetheless. We'll take a look at that in action here after our lab exercise for today. And then we're going to look at the importance, again, of research and trying to develop a really strong library of reference images that will help us navigate our kind of decision-making process as we create our own house this week. Okay, so our big assignment this week is to do an architectural rendering. Okay, so we're going to be building a true three-dimensional house. Okay, if you take a step back and look at the type of work that we're going to be exploring, there's a lot of little pieces in here that all need to work together harmoniously to create the illusion of a house. So we'll be talking about that, and we'll be talking about some efficiency workflows that will help us get through the initial stage of the initial kind of rough out of our house pretty fast, some ideas and some concepts. If we travel over to Canvas real fast and take a look-see, there's a couple things in here that we're going to do. Okay, so of course our homework this week is going to be a house. More on that later. It's going to be a two-part assignment. This week we're going to exclusively focus on the geometry. And then next week we're going to talk about the texturing of our house and the lighting and rendering of our house. Okay, our rendering pipeline is going to shift a little bit. I have an exciting announcement here in a minute, one of which I think some of you guys have already discovered. More on that in a second. That will change our discussion about rendering. Immediately, though, what I want to do is our Lego brick lab assignment. Our Lego brick lab assignment really allows us to look at some construction technique, how we can glue a whole bunch of parts and pieces together to get a really great result. Okay, so let's jump over to Maya real fast and look at how we can create our Lego brick. The big goal for our Lego brick is to have it be one contiguous polygon. So this isn't just a simple square with 6 little cylinders kind of squished down in it. What we're striving to create here is a true polygonal mesh that's contiguous. So all the polygons are welded together. Now in that, the outcome of this entire conversation and this entire kind of sequence is a mesh that's going to create some very defined illusions for us. And I want to zoom in on the banner image here so we can see the benefit of having all of these parts and pieces kind of connected. All right, so if you look at the boundaries between the little cylindrical nubs of the top of our Lego brick and the cubic base of our Lego brick, look what's happening to the lighting in there. What do you guys see at that intersection between those two forms? Yeah?
The shadows are not even, I would say. Maybe that's just me.
Yeah.
They are seemingly offset slightly from each other.
I like it. Yep. Okay. I like it. What else do you guys see? Now really look at the intersection of the square and the cylinder. You're getting there. You're getting there, and you're probably looking at this, right?
I can see some light on the outside.
Yeah.
If you look at the middle one there, if you look to the right of it, you kind of see a light right there.
Yeah, we're collecting a specular highlight there. Okay. If these were two intersected pieces, there wouldn't be a natural radius between these two pieces, so we wouldn't be collecting a specular highlight. Okay. So this little radius between the cylinder and the cube base itself is really what we're after. It truly makes these pieces feel like they're glued together, that they're all one piece. Now, it takes some effort to kind of create these radiuses. I'm a big believer that that's part of our job as a 3D modeler. This is how we earn our union card, as they say, right? This is fundamentally our responsibility to make the illusion of our model feel real. And these little highlights that are created by the manufactured connection between these two elements is what we're after. Okay? So the output of this entire assignment is one connected Lego brick. Let's jump back over to Maya and see how we can start doing this, because we got to start doing some math, okay? And we got to start figuring how we literally can take a round cylinder and glue it into a square hole. Challenge, right? a challenge. That's what we're trying to do. Let's jump over to mine and take a look at what we got. All right. So what I'm going to do and how I'm going to start off is with a very simple two-dimensional polygonal plane. Now, in our polygon shelf, we've been adding three-dimensional spheres and cylinders and cubes for the entirety of this semester. There's one other option here that I want you to look at, or just be aware of, excuse me. Oh, and here's my little surprise, which is why our conversation about rendering is going to change ever so slightly next week. We've been gifted some 35 licenses of Pixar's RenderMan from Pixar. So our rendering pipeline is going to shift next week a little bit. We've been working in Arnold, which is a good rendering engine, but RenderMan is definitely the best, okay? We're lucky that Pixar has made all of their tools that they use for all of their in-house productions available to the rest of the world, okay? So we're going to be using the exact same tool set that Pixar uses to draw all of their animation frames starting next week. We're not going to do it this week because we're still trying to get it installed in the lab and some other places to help you guys learn how to use all this stuff. So next week is going to be kind of our official first week of support of RenderMan, and I'm really excited about it. It is markedly better than Arnold, right? It's a whole lot easier to use. The shaders, the lights are fantastic. I think you're really going to enjoy it. It's going to be a great experience for you guys. All right, let's jump over to that poly shelf and start looking at what we're going to do here. Okay, so poly modeling. Now we've been making three-dimensional objects, okay? But check it out, we also can make two-dimensional planes inside of the poly modeling shelf. Let's just do it real fast. Let's throw one in there. There it is. I'm going to turn my grid off. This is what we get, okay? Now I'm going to reduce this down in size. In order for us to create a cylinder that's going to go in here, we need to make an opening on our square, okay? We need to have a hole in order for us to connect another piece to it, okay? I want to reduce the complexity and the resolution of this shape very directly by traveling over into my channel box. There we go. Then way down here, oops. All right, since we got RenderMan in here, we're going to see a lot of this stuff now. But here's the inputs for the poly plane. Let's do this. On the subdivision width and height, let's reduce this down a little bit. Let's start off with a 4x4. There we go. A 4x4. Can you guys see all those polygons? Yeah, great. Now, we're going to make some changes to it. Oops, I'm sorry. I'm going to hit the F11 key to go into my Polygon Selection engine, and I'm going to select those 4 interior polygons and delete them. Command backspace. Remember to do Command backspace, or Control backspace, excuse me. What does Control backspace do, and how is it different from just the regular backspace? It's an important distinction, and let's kind of revisit this for a second. So if I was just to simply select those polygons and hit the backspace command, okay, what's left is some verts, or it potentially could leave a vert here in the center. In this particular situation, it didn't, but I can't tell you how many times just hitting the backspace key leaves the verts that are associated with those faces inside of your scene. With a two-dimensional plane, it looks like it's not going to do it for us this time. Point being, we just got to be very careful. Out of habit, I just could do Control backspace every single time to really delete those polygons. Now the reason we did this is to create an opening, a physical hole where a cylinder is going to be clicked into, okay? Let's do some counting. So I've changed my selection mode over to edges, and I'm simply going to double click on that opening, and you can see from the modeling toolkit's little command line here, we have 8 edges selected. It's awesome. So in order for us to connect a cylinder into this square with this number of openings, we need to have these number of edges match. The number of edges on the opening have to match the number of edges that go around the base of the cylinder, okay? It's a 1-to-1 connection ratio. If we can keep it easily in powers of 4, or the cylinder size with powers of 4, it's better. Let me show you what I'm talking about here as to why it's better and stronger. Okay, I'm going to leave this object as is, and once again, I'm going to create a two-dimensional cylinder. So what I did here is that I just did what's called a poly disk. Okay, let's change the subdivision to quads, not quads. Oops, I wanted triangles. Number of sides, let's put that to 8. Caps would work. Circle, not hot. I'll get it here eventually. There we go. That's what I was after. Hello, can I help you?
Sorry, I'm slightly lost.
All right. So I've just made a poly disk. FYI, I'm just making a cylinder here. It is wholesale identical to doing this. Okay. You could also just make a cylinder, which is totally cool. Okay. And then just change the number of subdivision axes. I want to put that down to 8. 6 to 1, really half a dozen to another. Okay. Now I want us to spend some time looking at this cylinder here real fast. Okay. Because there's some considerations that we need to be mindful of when working with cylinders as a whole. Okay. First and foremost, the structure of our cylinder. I have an idea here that will help, I think, make this a little bit easier to see. I'm going to take my cylinder and I'm going to duplicate it, duplicate with special, and I'm going to, let's see, I'm going to make a copy of it, but I'm going to duplicate the input graph. I didn't want 6 of them, excuse me. Oops, and let's do, yeah, that's fine. All right. So now I have 3 cylinders inside of my scene. The first one I'm going to leave the subdivision axis at 8. The second one, I'm going to change the subdivision axis to 11. And the third one over here, I'm going to change the subdivision axis to 12. Just so we can create a nice little comparison as to what we're working with. Okay. All right. So here we go. Here's my 3 cylinders, and I want you to look at the structure of how all 3 of these cylinders are created. So physically look at the edges that are going around the outside, the circumference of our cylinder, and how they're laid out in comparison to each other. Now 2 of these have a very defined pattern, and one of these is slightly different from the rest. Look at the structure. Look at how these edges are physically distributed around the cylinder, around the cap of the cylinder. We've got an 8, an 11-sider, and a 12-sider. What can you tell me about these 3 cylinders? How are they the same, or how are they different?
The middle one has a flat end on one side and a pointy one on the other.
I like it, and specifically what Andrew's seeing here is probably this face right here. That one. Okay. Doesn't go to a point, it just flattens out. Is this really actually a circle? Not really. It kind of looks, in finger quotes, like a circle, but it really isn't circular. With that flat edge there, it doesn't give us the illusion that we're after. Bingo. I like it. Okay. And specifically, if you kind of take that ball and run with it a little bit, the first and the third, so the one that's been created with 8 sides and the one that's been created with 12 sides have what are called cardinal poles inside of the model itself. Let me show you what I'm talking about. If you're looking at a compass, of course we have north, a vert at the north, south, east, and west. This is truly a symmetrical object along 2 of our 3 axes. That's what we're looking for, right? Objects that are symmetrical are easy to edit and easy to work with, okay? There's a pattern in the structure that we can then take advantage of. If you look at the 12-sided cylinder, even though it has 4 more edges distributed around the circumference of the cylinder, it still has that exact same pattern. North, south, east, and west. These are very predictable structures that I can use and take advantage of as I kind of navigate through our modeling process. I'm a big believer that when we're working with cylinders, first and foremost, even sides only, right? Look at this 11-sider. Ooh, thumbs down, right? Because of that edge. It's got a pretty uniform, distributed kind of angle. Then it gets over here and it kind of completely messes up the pattern. Thumbs down, that's going to be difficult to work with, right? So at the very least, we should be striving to create cylinders that have 8 sides. That way, all the edges that are responsible for creating that circle are evenly distributed, right? Even better, we create cylinders that are divisible by 4, okay? 8, 12, because now their patterns are symmetrical, okay? They're symmetrical along the x-axis and along the z-axis, okay, which is what we're after. That makes it very easy to work with. So like 8, 12, 16, 20, 24, there has to be a darn good reason for me to go above 24 these days. But those are all cylinder sides that I should be very mindful of because they're predictable. They're symmetrical. I can use the mirroring tools to help me get through this process. And this is the kind of the workaround part, the math is just easier. The math of working with these cylinders, especially when connecting these cylinders into a square, is just easier. Okay? I'm going to get rid of my 11 and 12 friends here, and we'll jump back in and start looking at how we can connect all these together. All right. So I want to move this accurately. Let's do this. I want the center point of this object to be right smack dab there in the center of our origin. So I'm going to hold down the X key just to do a little grid snapping here. And I want to scale that cylinder down so it's inside the opening of my square. Okay, there we go, looking good. I want to look at my scene from the front because if we examine what we have here, the cylinder is definitely below the plane of the square. I want that bottom edge to be the exact same location as my square. How could I do that? How could I get the bottom edge of that cylinder to be exactly in as the same location along the y-axis as the square that I'm trying to connect all this stuff to? Ideas, how can we do it? Now, Pat doesn't like close. Pat doesn't do close. Pat wants exactness. Pat also talks in the third person today, apparently. I want precision. I want to know beyond any reasonable doubt the location of the bottom of the cylinder is identical to the location of the plane that I'm trying to connect it to.
Mark the origin point down to the center and then move it up.
We can't move the origin point, okay? Well, so you're talking about the pivot point.
Yeah.
Yeah, that's a good idea. It's a great idea. So we can move the pivot point down to the bottom, and then what?
And then snap it.
Snap it up. I like it. That's a great idea. Absolutely. How do we change the pivot point for our objects? What keyboard shortcut gets us into the edit pivot point mode? D. Yeah, D is in delta. Okay. And now I'm going to hold down the V key while I click exclusively on the Y translate arrow, because that will do vertex snapping. V is in victory or vertex. Now with my pivot point precisely snapped down there at the bottom, I'll hold down the D key once again to get out of that mode. And with the move tool activated, I now can do a little grid snapping. It's a great way of getting it where I wanted to go. Now, if my square was not at the origin, if it was slightly offset, right, slightly above any sort of grid square, sorry, okay, because it's way up there, instead of doing grid snapping, what could I do with my cylinder? Vertex snapping, right? That V key, once again, The cool thing about working inside of our 3D tool set is that all these verts are known. The location of all these verts are understood and known by the entire system. We should take advantage of that. So once again, fire off the move tool, but this time I'll hold down the V key and I'm just dragging up. So I know beyond any reasonable doubt that I'm exclusively translating this object along the y-axis. It's a dangerous practice in my opinion. I see people doing this from time to time. It's a dangerous practice to grab this center box. Why is it a dangerous practice to grab that center box versus one of the arrows with the move tool? Why would this be bad form? Bingo. Do you know exactly how this object is moving? No. You probably could guess, and you may be right, but you also may be wrong, right? The only way to know full show is to grab a specific arrow. I want to move it up, I'm only grabbing the up arrow, right? Or in this case, the translate y-axis arrow. Hold down the V key, I'm going to grab this translate up arrow, boom. Now we know beyond any reasonable doubt that I've snapped the bottom of that cylinder to the exact same location as my little square. Let's go back into perspective, take a look at what we got. And now we can start doing some work. Now remember the goal here. We're trying to literally connect this cylinder to that square to start making our Lego brick. Does anyone know the next step in this? We've actually done it a couple times before. We're going to get there. Before we can bridge, what do we need to do? We do need to delete the faces, and since we're talking about it, let's just do that. We need to delete the faces down here at the bottom. Okay, Control backspace, excellent. In order for bridge to work, what do we need to do next? We need to combine the items. You got it, right? Because the bridge tool is only going to work within the polygons of one item, okay? Or one object, excuse me, not items. So let's combine these guys. So we'll do mesh, combine, whoop. Now they're all in the same one. The moment we do a combine, what's the first step after that? You're right. What is it? Delete the history, right? So we get rid of all those references to their previous states, okay? Specifically, I'm talking about these two objects that are over here. So by deleting our history, this guy, bloop, now we've made this new mesh object completely independent from its past, which will allow us to cleanly walk forward in our modeling sequence. So now we can go over, select some edges, and start bridging these things together. And hold down the Shift key, double-click on the opening, and now we can run bridge. Okay? And you can see that it's made a real legit connection between the base of that plane and the cylinder itself. Cool, huh? This is how we literally start connecting these parts and pieces together. Let's take this one step further. Over the last couple of weeks, we've been talking a lot about subdivision surfaces, right? Our Lego brick this week needs to be a subdivision surface. So we want to use that great smoothing algorithm to put this entire mesh under tension.
Is it a problem if my object just shows up as yellow?
Hit the B key. Someone before you has hit the smooth select tool. Yeah.
What did I do wrong?
Ah, okay, cool. So, not wrong at all. What's happened, I'm going to go back so everyone can see what has happened to Sierra's. So, oops. This is what your mesh probably looked like. It was twisted. You get these little twists in there. Yours is, I think, a little bit more extreme. The verts don't match their orientation to their connected friend. So what you could do as an alternate kind of method here, before you bridge, or even after for that matter, just rotate that bottom edge. Okay, I've really made it extreme here to showcase what we're talking about. Yeah, that's probably what you were getting, right? Just a real extreme twisting. If you were just to grab that bottom edge and just rotate it back, I'm going to hold down the J key to snap in 15-degree increments. Yeah, there we go. Now we're up and running. That happens sometimes. Just cylinders and the openings get out of alignment with each other. All right. So does anyone remember how to enable the subdivision surface algorithm on our mesh? What's 3? Yep, let's do it real fast. This is the 3 key, and there it is. Okay, cool, huh? Now we're taking advantage of the smoothing algorithm, and the little nub of our Lego brick has smoothed out. But man, this part up here has kind of turned into a little bit of a nightmare, and I certainly want to be able to control the radius at the bottom where the cylinder connects to the plane. How could I do that? How could I very quickly go in and start shoring up those edges and controlling how the transition between the polygon planes is happening? Yeah, let's do some edge beveling. Love it. I'm going to start down here at the bottom. I'm going to hit the 1 key. Oops. Select the object, hit the 1 key to go out of the subdivision mode. And now I'm going to start selecting some edges. I'm going to do that bottom transition first. I want to control how the subd algorithm influences that transition. So I want to add some additional edges in here. We went over this before, but how many new edges do we need to add to the existing surface? 2, right? We're creating an edge sandwich. The middle, the meat of our edge sandwich, is the original edge. We need to add 1 above and add 1 below. 3 total to control how the algorithm is going to influence our geometry. The Bevel tool just does such a wonderful job in doing that. Okay? Specifically, the chamfer. If we turn the chamfer off, look, it automatically does exactly what we're looking to do, right? It adds 1 below, right here, and adds 1 below, above. Yeah, like the Fonz from Happy Days. Anyone? Kind of dating myself a little bit. I said that to another class, and everyone's like, "What's the Happy Days?" And I went, "Are you kidding me? You don't know that, right?" It's all these pop culture references that are starting to slowly fade out of our common, standard convention.
Okay, I got it.
All right,
I watched it with my parents. So.
there you go. All right, of course.
Knows what Gilligan's Island is.
Yes. A 3-hour cruise. Okay, so the fraction still is going to allow us to increase that bevel. Now, when you're doing this, here's kind of a great little trick, something that I would recommend that you look at very carefully. See how this edge at the bottom is getting close to its neighbor over here? This is cool, this is cool, this is cool, this is cool, not cool. Okay? We don't want the edge, this vert down here, to intersect out with its friend. Get it close, that's cool. Don't have it terminate, because now we've created some triangles inside of the scene itself. So let's just do it. Let's go back. I'm going to back it off a little bit. Something like that will do just fine. Hit the Q key to drop the tool, and let's see how that affected our mesh by selecting the object and hitting the number 3 key to subdivide our mesh. And things are starting to look pretty badass. I like it. Now we're controlling it. Let's do the exact same thing at the top, where the top cap of our cylinder transitions into the height. Unsubdivide. You always want to do this work when it's unsubdivided, by the way. Select the boundary that I want to control. Let's just run a bevel. Chamfer's off. The fraction is just way too big. Something like that. Q key to drop the tool, and then I'm going to subdivide the mesh by hitting the 3. And there it is. Voila! We're up and running. Okay? Everyone try to do this real fast. Everyone try to get a cylinder connected to a square, and then add in this interior structure so that it looks appropriate when we hit that number 3 key to subdivide the mesh. Ready, set, go. Let's do this real fast. Okay, so now that we have all that stuff put together, how are we to create our little Lego brick? Let's talk strategies. As I mentioned earlier, it's all about sequence as 3D modelers. We have to think 8 or 9 steps ahead, because what we're doing now is going to influence what we're able to do in the future. Okay? We can duplicate special. I like that. That's a great way of working. And we don't even have to use duplicate special. We can just do a straight up duplication and then do some vert snapping. Let me show you specifically what I'm talking about, right? I'm going to unsubdivide. And I'm just going to do a straight up duplicate. Okay? And now, check it out. Change the pivot point. Do some vert snapping. There it is. Okay? Get out of that pivot point mode again. And now I'm going to do vert snapping and boom. Those are together. So we don't have to do the math sometimes. We can just use the existing information, the geometry that's sitting in the scene to drive our modeling sequence, which is a great operation, which is a great thing. Now, at the end of the day, this is all going to be one contiguous piece, right? So I have these two things kind of butted up next to each other. What's next? Combine. Yep, got to get them in the same object. Let's do that real fast. Once we combine these two objects, what's next? Delete history, of course. Okay, they're in the same object. They look as though they're one piece, but are they one piece? No, they're two separate pieces. Let me prove it to you. I'm going to go back to my faces mode and check it out. They're two discontiguous pieces. I need to merge and weld all those points right down there at the center line, okay? Because I want to be able, or the ultimate goal for this, is that I should be able to just go double click and have the entire thing get selected. If all the polygons from my Lego brick are selected when we double click on it, that means they're contiguous. That means they've all been welded together. It's not a series of pieces. It's all one interconnected piece of structure. So check this out. I'm going to grab these two pieces, and there's an excellent, excellent tool called merge. Okay? As one might imagine, the merge tool is going to merge some verts. That's all it's going to do. Okay? And it's right there, merge. It's merging some verts. That's all it's going to do. All right, so merge is going to look at a distance. Okay, this is the default values, 0.01. It's basically saying if two verts are 0.01 units away from each other, join them, merge them together. If we keep increasing this, this is kind of fun. This is just an experiment. Watch what happens when I increase this value. Now it's at 0.1. So if the verts are 0.1 units away from each other, they're going to merge them. And I can just keep going here. I can merge all those verts down, which isn't what I want, right? Now sometimes, and I'm just going to go back, okay? Sometimes the verts that are close to each other, like I have over here, see how at oops, I apologize, got too close. At 0.01 right there, watch those. See how they join together? Boop, boop. So we got to be careful. There's another way we can do this, because I don't want, these are close to each other, and I don't want those two verts to accidentally get merged. So here's what I'm going to do. I'm going to go back in time until the tool was, and I can't recommend it enough, honestly. So be mindful of that. Be mindful of that, okay? So 10 verts, and now with those verts selected, okay, check it out. I want to run merge again. Bloop. And look what's happening. We're filtering. Now, this part of my mesh over here where those verts are close aren't getting welded together, but all of that stuff has been welded together, which is exactly what I'm after. Hit the Q key to drop the tool. Let's test it. Let's go back into our faces selection engine. Double click, boom, everything's selected, so we know all those boundary verts have been merged together and welded. Okay? And now we have the underpinnings of what could be a really great little Lego brick as we continue this process on. Questions on some of these ideas? We can filter the tools with the selection. We don't have to influence all of the component pieces of our model. We can just select, hey, just merge these series of verts and ignore everything else. The selection engine is going to determine how and what the tools influence. So use it. It's part of our process. It's not just about selecting things so we can move and rotate it. It's a filter. Make sense? It's kind of like in Photoshop. If you're used to working with Photoshop, the selection engine of the pixels is almost identical, right? Whatever is selected is going to be edited. If nothing is selected, everything is going to be influenced by the tools, right? But if we just want to change, these pixels over here, we have to go in and select those pixels, and then the tools will focus just on those. Exact same idea here with our tools. Yeah, let's do it again. So the first thing I did, I'm going to go back in time a couple steps. The first thing I did, okay, I'm back at a point in my modeling sequence where I have two discontiguous pieces. Hit the 1 key to unsubdivide. The first thing that I did is just select all of these verts down here in the center. Now, it looks like they're already on top of each other, right? But they're separate pieces, and this little command line over here in our modeling toolkit tells me I have 10 verts selected, even though visibly it looks like I only have 5. So with those verts selected, the merge tool is only going to merge those verts. Okay? And when I want to hit the Q key to drop the tool. Then over here in our modeling toolkit, once again, it shows me now I only have 5. It's a good kind of visual confirmation that, in fact, I have merged our verts. Okay? Okay, so you're not, the verts aren't merging? Troubleshoot. Put on your detective hats. Why not? How do you know it's not merging? Good questions.
Brings this up.
Okay. So it's trying to do it, right? Put it back down to 0.01. And then drop the tool. See if that changes your selection engine. That little command line thing may not be updated until the current operation is complete. Another way to double check to see if the merge has happened is go into your Faces selection engine and just double click. If everything gets selected, you know you've merged some verts. Double click. Okay, let's do it one more time. Hold on a sec. Select these objects over here. No, just one at a time. Yeah, they're on different objects. That's why they're not merging. Got to be in the same objects. Check that as well. Got to combine it all into one object. These component tools are never going to work if they're on separate objects. Okay. Remember to delete your history. Yeah. Delete that bottom cap. That's going to influence your bridge. Yep, and also make it smaller so it fits in that opening a little bit smaller as well. All right, for those of you that got all this together, see if you can complete the Lego brick. Okay? Start modeling this out and try to create that Lego brick. Good. Try bridging it now. Delete those bottom caps. Start combining it together before you bridge it as well. Okay, so this little Lego brick assignment is a fun little puzzle for us. It allows us to continue developing our internal sense of sequence for our modeling tools, right? And that really is honestly kind of one of the challenges when it comes to 3D modeling, is figuring out how to make something that's really complex from very, very simple tools that behave very simply, right? Our sequence is incredibly important. How we make our objects and the sequence that we follow determines what we're able to produce. So let me just kind of show one additional part of the sequence. Now I've spent some time here, kind of, this is where we left off. I spent some time making the little nubs, okay? But now maybe I want to make it into an actual brick. How am I going to do that? What could potentially be part of our sequence?
You can grab the edges and extrude them down.
I love it. Let's grab the edges and extrude them down. In doing so, what that allows us to do, and I'm just going to grab the boundary here, extrude it down. I'm going to go back in time. I was pre-flooding this before we got started, and I think I didn't go back far enough in my history. Okay, let's try it again. Yeah, I'm getting some normals, some problems with my normals. So let me just do this real fast. I was monkeying with a tool that I had never explored before, and I think I just hadn't gone far enough back in my undo queue, but looks like it's not going to behave correctly. That's okay. The point being, it will still work. I can just extrude it down, right? Now, the benefit of extruding it down is that the polygonal structure that we established on the top is now then created for the sides. The loops continue all the way around the mesh, okay? I don't have just a single polygon here that I merged to the top. I've now extended that polygonal shape downwards, okay, to make the walls of my little Lego brick. Now, I want to try to get this into something that looks similar to a Lego brick, and I apologize, I got to go in. This happens from time to time. This is just Maya being Maya. Whenever you have a black face like this, we simply just need to reverse the normal. There we go. Okay, the same thing over here. And this is entirely due to the fact that when you guys were on break, I was monkeying around with this. Yeah, there we go. Okay, so how am I going to close that bottom? Because the Lego brick is completely solid. Well, it's got a little bit of a divot underneath, but it's solid. It's not hollow like we have here. What's one way we can get there? Bridge. I like it. Let's try that. I'm going to select that entire boundary, and I'm going to deselect the ends over here. Same with its neighbors, because I only want to bridge across this way. So now when I run bridge, haha, awesome, looking good. Now in addition, I want to have these polygons coming this way, loop around towards the bottom. I can use multi-slice, insert edge loop tool. There's a lot of ways for me to get some edges running from screen left to screen right, but the bridge tool also allows us to increase the divisions, which will start slicing up those new bridged polygons for us, okay? Q key to drop the tool. Now, I'm heading in the right direction here, but what it didn't do is do a really great job of merging all those verts down there, okay? And I just hit the 3 key. That's kind of sometimes my good double check to see if things are working the way I want them to work. Yeah, it's not, these verts over here aren't merged. So I'm going to go back into my Vertex Selection engine. My camera-based selection is off to ensure that I'm getting all the verts that I'm looking for. There we go. And now let's run merge. Hit the 3 key to subdivide, and yeah, that's what I'm looking for. Okay, starting to look good. This also puts me in the driver's seat for the next modeling operation. I'm going to delete my history real fast. And now I can grab all of this. Let's just do a simple extrusion with a very small offset to start creating those interior walls, right? Hit the G key to fire off the extrude tool once again. Just do a little bit of that, and voila, now we have the underpinnings of a really great Lego brick. You certainly could, since we have a very similar structure on the bottom, continue to create little holes and openings for the actual inside of the Lego bricks. That's, I mean, if you wanted to do that, you certainly could. With the correct structure in place, those edits aren't difficult.
What I did was I just took the top part and I duplicated it and put it as the bottom.
I love it. reversed it, bridged it. I think that's a great way of working. That's another way of doing it. Excellent work. Good job. All right. Let's start looking and talking about our next big homework assignment, our next big project, which is going to be a house. Okay? So you're going to be designing and creating your own house. One of my big goals of this class is to introduce you guys to a lot of different applications of the 3D modeling tool set. And of course, the low-hanging fruit in our world is, of course, the architecture world. Building a model of a 3D house and seeing its spatial relationships and proportions is a whole lot easier in Maya than it is actually building a damn house, right? Actually, I did this for a client a number of years ago. She was making a little web hub, and she wanted her entire team in her office to be, or her entire web team to be sitting in this one kind of area, and she was going to build kind of a custom workspace for them. And she drew some things up on paper. We started kind of iterating on these ideas, and I said, we should really build a 3D model of this to see if this is going to work, right? We really won't know for sure until we physically build the walls in 3D, proportional and scaled pieces of furniture in the space to see if it's big enough, to see if it's fundamentally going to work. And guess what? It didn't work. The paper idea didn't work until we physically saw it and laid everything out in 3D. That was the time when we said we need to make this bigger. And moving a wall in 3D is a whole lot easier than moving an actual wall, right? So that was time well spent. I spent the entire day measuring every door, every window, every wall in that house, right, or in that office. So in the architecture world, our tools have gotten to a point where we can create some really great, accurate, specific results very, 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 very quickly, right? This is low-hanging fruit for us. This is one of the opportunities that 3D modelers naturally find. I know a lot of guys and gals where this is all that they do, is they do architectural renderings. They make 3D models of of a house, and then that's used as part of that architecture firm's workflow, right? So it's a nice landing spot for our tool set, but we need to think about how we create our models a little bit differently. One of the considerations that we need to be mindful of is uniformity. There are some expectations that the windows be generally the same size, that doors be generally the same size or an appropriate size. So we need to be very, very mindful of scale. We need to be very mindful of proportion as we start to enter into this world, okay? Your mission this week is to create a model of a house. I don't care what house. Shoot, I say make it easy. Make it your own house or your own apartment complex or a house that you see every single day. The challenge that we find in any 3D model is just familiarity. So if you start off with a house that you are very familiar with, this project's going to be a whole lot easier. Okay? In addition, we're only modeling the exterior of that house, okay? So don't worry about the interior floor plan. We're just looking for the general footprint of our house. So don't worry about the insides. That's an entirely different ball game, right? We're just looking at the outside. Now, when it comes to the exterior of the house, there are some big-time challenges that we need to kind of look to tackle. First and foremost, the actual footprint of the house, okay? The profile shape from the top, that's something we need to consider, okay? In addition, the roof lines, also a big challenge that we're going to look to overcome. How are we going to create these wonderful roof lines that meet with the walls? Idea, right? Another challenge is the windows and the doors. Last time I checked, most windows in a house are going to be generally the same size, or at the very least, they're generally going to be the same height, okay? The width could be different, but the height is the same. Shoot, just look around this window, or look around this classroom, right? Look at the doors, the windows here on my old office, the door in the background. The height of all of those windows is the exact same. The 3 windows in this size are literally the exact same size and proportion to each other. So this uniformity is important. It's part of the style and it's part of the expectation for architectural visualization. How are we going to create that uniformity with very primitive tools inside of Maya? Well, the answer to a lot of the questions that we're going to be looking at today are Booleans, okay? To a certain degree, I'm opening Pandora's box, but this is a good box to open because it allows us to work very quickly and to iterate on our designs with some very powerful tools. Booleans allow us to take 3-dimensional objects, okay, and use the size, scale, and proportion of these different three-dimensional objects and allow them to cut pieces out of other three-dimensional objects, okay? So we're going to take squares and use the shape of that squares to subtract another shape of a square, okay? It's going to be pretty neat. The Pandora's box that we open, unfortunately, is with our structure. Oftentimes, internally, the geometric structures of our surfaces can get a little wild, okay? So we need to be mindful of what this engine is giving us and ensuring that we're doing our due diligence as good practitioners of our craft to clean up some sloppy geometry and ensure that everything's a triangle or a quad face, okay? Let's jump over into Maya and look at how we can use this Boolean engine to start creating our house, okay? All right, so I'm going to start a new project file real fast. New scene, don't save, bye-bye, okay. Let's tackle the easy low-hanging fruit of footprint, right? The overall shape of our house. We don't need to try to describe every single interior room, but we do need to have a really great, kind of fixture on what the exterior floor plan or the footprint of that house needs to look like, okay? If you can find some reference, that's a good thing. Shoot, if you're doing your own house, walk around the house, figure out where all the angles are, figure out, where the bends in the walls are. I have a 3D model of the Cosmo building that I made 1,000 years ago when I first started teaching here. And boy, if you want to get 1,000 dirty looks from 1,000 different places, just walk around this campus with a gigantic tape measure, and people will stop you and ask you what you're doing, right? It was amazing. I had professors that I hadn't even talked to, like, what are you doing? It was a fun afternoon. And then they're like, oh, you're making a 3D model of our building? Can I help? And it's like, yeah, hold the tape measure. I'm going to measure this wall. Anyways, okay. So there's a really great tool that we can use to help us very quickly create a floor plan, a footprint. Last week I spent a lot of time talking about curves, the Bezier curves. Those are excellent tools to create a two-dimensional plane. But there's another tool that I want to draw focus to. Because what a curve doesn't do is actually create geometry until we start revolving it or doing some other sequence, right? Or adding a curve into some other sequence. Let me show you a really great tool. I'm going to look at my scene from the top. And simply, it's the Create Polygon tool. The Create Polygon tool is ultimately going to allow us to make a custom shaped and a custom polygon, right? Let's do it real fast. Under the Mesh Tools area. Again, I'm looking at my scene from the top. And as I click inside the viewport, I can create a really great custom shaped polygon. I'll hit the Q key to drop the tool, and it goes black. Well, why did it go black? Do we actually create the shape? Yeah, absolutely. Again, if we look at our scene from perspective, the surface normal of that shape has just been flipped. Now, let's take a look and go back for a second to see how we can get that surface automatically facing upwards into our three-dimensional scene, okay? The direction that we create our polygon, or the direction that we create our points along the polygon, is going to determine the surface normal. I'm going to delete that. Let's do it one more time. Create polygon. Again, I'm going to look at my scene from the top, and notice that I'm going to work clockwise. Okay, Q key to drop the tool, and the polygon is facing down. Same thing, create polygon, but now I'm going to do it counterclockwise. Q key to drop the tool, and now the polygon's facing up. So the order in which we create the verts, or the direction that we create the verts, is going to determine its surface normal. Something to be mindful of. Yeah, you can always flip it after the fact just by selecting the polygon and hitting reverse, but sometimes you just don't have to, right? If you're mindful of how the tools work, we can get the result that we're looking for from jump, initially. All right, so that's a really funky looking floor plan. But the cool thing about the Create Polygon tool is that the output of all this is just going to be verts, right? And now I can do whatever I want with these. Okay. Now I can continue to go in and add some new geometry and start fleshing a lot of this stuff out. Last time I checked, though, a lot of architects like straight lines. The walls generally 90-degree angles from each other and so forth, right? if you look at the top of my crazy looking polygon here, these two verts definitely don't make a straight line. They're at an angle. Okay, I've just made it really extreme. How can I take that polygon, or excuse me, that edge at the top of my polygon and ensure that both verts that are responsible for creating that edge are perfectly horizontal to each other, perfectly flat? Did anyone stumble upon this? This is a great power user trick. This is Pat's power user trick of the day. I feel like I should brand that. Pat's power user trick of the day. Da-da-da, have a little theme song or something. I don't know. Okay.
It makes a 90-degree angle.
Well, we're going to make it a straight line. 90-degree angles are coming next. Yep. Here it is. It's really easy. This is one of those things where I face-palmed a dozen years ago when someone showed this to me, right? Because I used to do this way. I was like, oh, I'll just move it, hold on the V key, do some vert snapping, and try to get to work. And then it's like, no, it's not working. You know, I don't like this, right? There it is. Vert snapping will work. That's a hard. I don't like hard. Okay. Here it is. If I grab the edge, okay, let's run the scale tool. Scale it down. Okay. See how, boop, perfectly flattens it out. Nice. Do it one more time. And this is how we can create some really quick 90-degree angles, okay? Maybe I want that wall and that wall to be 90-degree angles from each other. Well, I have one that I know to be perfectly horizontal, so if I was just to scale that guy in, now I know beyond any reasonable doubt that that one and that one are 90-degree angles from each other. Once we create one perfectly straight line, we then can start building 90-degree angles or whatever angle we want off of that. It becomes a reference point for the rest of our sequence, okay? So I think I'm going to have this be just a really fun-looking house, okay? Something like that. That's good. That's a crazy house. This needs to be straight, though. Let's flatten that out. Oops, I missed it. There we go.
What was the method for that?
It's just you scale it. It's so easy, it's hard, okay? Scale it down. Now it's a 90-degree angle. Yeah. You got to start with one, though. You get to have one perfectly flat edge first. And then we're free to go in and start moving these around and doing whatever we want to do.
I hate that it's that easy.
I know, right? I'm sorry. I'm sorry. I get that a lot. Oops, I thought I grabbed both of them. There we go. So let's go back. I'll just leave it like this. This will just be a weird looking house. Why not? Oops, I apologize. All right. So that's going to be the floor plan of my house. Kind of a weird looking shape. I'm cool with that. Maybe this is where the front door is going to be, way out over here. Maybe my house, this is where my back patio is going to go. I like to barbecue, so that's where my barbecue is going to go, off the back window. Okay. But now I need to start thinking a little bit more about the sequence. Okay. Now I'm trying to create a house that has the ability for windows and doors, right? For windows and doors, I'm going to need to punch a hole in the wall, right? In order to punch a hole in the wall, that wall needs to have some thickness associated with it, right? An idea. If we have thickness on our wall, we now have something that we can punch through to create a true opening in the walls themselves. So let's start creating the thickness. And I'm going to do this just simply by selecting that one shape, okay, and running, of course, good old extrude, right? Now, with the extrude tool, there's two things that we need to do. First and foremost, the offset here is going to allow me to create what I'm after, this boundary polygon, okay? However, there's two polygons sitting right on top of each other. See how it's kind of flickering? See that flicker? This is called Z-fighting, okay? When I have two polygons that are sharing the exact same space, the OpenGL engine doesn't know which polygon to draw, so it's trying its best to draw both of them simultaneously, right? Whenever we have Z-fighting ending up in our mesh, that's a really good indication that we have two polygons, okay? Look carefully at what I have selected. I have this inside one selected, but check it out. I also have a double, and this is everything. This is just kind of a byproduct of the Create Polygon tool. I can just simply delete it, do Control Backspace, and now we're on our way. And also, this interior one is going to get deleted as well. And now I have what kind of looks like a basic floor plan for my house, the walls, in 2 dimensions, okay? How can I start raising the roof here, making some walls? Extrude, yep, you got it. Voila. And there we are. Now you can do whatever height that you want. This is kind of part of the challenge of working inside of Maya, is figuring out the spatial relationships to all this. But that looks pretty good for me. And now I have the underpinnings for my walls. Okay. Now comes the fun part, because I need to start punching some windows in here. And I want all my windows to be kind of the exact same size, right? There should be a certain expectation of uniformity inside of our entire production pipeline, right? How could I cut in some windows? I physically have to have holes in my walls to get what I'm after. How could I do that with our existing tool set in tow? We're going to get to Booleans, but not knowing anything about Booleans, how can we create some windows?
Make some cuts, then delete, and then bridge.
I like it. Make some cuts, then delete, then bridge. So multi-slice would be a great way of getting where I want to go. Or multi-cut, excuse me. I apologize for misspeaking. So I can go in, I'm going to hold down the control key, and we can say that's maybe where the top of the windows are going to be. This is where the bottom of the windows are going to be. But what it doesn't do is it doesn't do this inside loop, right? I have no idea where to place this inside loop, because it needs to be in the exact same height and the exact same location as the outside loop to make a clean cut, right? I mean, I could get there with some vertex snapping. I could get there, right? I could probably figure out that math pretty quickly, but man, it's a lot of work. And you know, at 3:30 on a Thursday, a lot of work doesn't sound good to me right now, okay? In addition, what multi-cut doesn't do, nor will it ever do, is figure out the vertical slices. I want all of my windows to be the exact same size, right? I could slice one and then slice one, but how am I going to be able to figure out the width and then repeat that pattern over and over and over again? Challenge, right? This is what I'm talking about. I'll show you what I'm talking about so everyone has a point of reference. Again, multi-cut or any number of the cutting tools, I can do one, no problem. I can make, you know, there it is. Let's just pretend that that polygon right there is going to be my window. Boom. I like it. But how do I make the second one? If I want the second one to look identical to the first one, I have a challenge that I need to solve, right? I have a big-time problem. Thus enter Booleans. Booleans are a way for us to make destructive edits to our mesh based off of the size, scale, and position of other pieces of geometry. So we're going to take cubes and subtract and make holes out of other cubes. Okay? We're going to take a cube and we're going to punch a hole in our walls with that cube. It's pretty easy and it's pretty fun too. Let me show you what it looks like. I'm going to go back in time a couple steps, get rid of all those slices. And now I need to physically start creating some geometry that's going to represent the windows. Okay? All right. Let's just make a cube real fast. Just straight up polycube. And now as I scale this up, I'm thinking about proportion. Let's look at it from my scene from the top. I'm going to move this out. Now I'm trying to think of how big do I want my windows to be? Where do I want them positioned? I'm also going to intersect them like this. Physically plant them in the walls. Maybe that's a good window width, perhaps. It's a little low on the walls. Windows are up a little bit higher. Okay. I'm making Pat's Modeling Shack right now. Or Pat's Pizza Shack. Maybe Pat's Pizza Shack would be better, right? I am akin to pizza. I love pizza. So good. Anyways, I've digressed. So this is a good kind of placement for the windows. Good size. And now I can make the hole. I want to make a copy of this window before I go any further, just so I always have one. Over in my outliner, let's just do this real fast. Let's just call this window. There we go. And I'm just going to do Command D to duplicate it. That way I have one in my back pocket. All right. Now, in order for us to cut a hole in my walls based off of the size of my window, The selection order is critical, okay? Only you can prevent forest fires, right? This is the part that you have to manage. The order in which we select the objects in the outliner or the scene is going to directly determine how the tool works. Let me show you what it looks like. First and foremost, we're going to select the thing that we want to keep. Which of these two objects do I want to keep? The walls. And let's make it easier for everyone to figure this out. I'm going to change the name of my my object over here to walls. So of course I want to keep my walls, but I want to cut a window into it. Okay? So I'm going to select the walls first, hold down the Command key, select the window second. Okay? Before I go any further, and I apologize for getting out of the way here, I'm just going to put my extra one off to the side. So walls first, go to object mode. Walls first, window second. Okay? What we keep, or what we're trying to keep, is always selected first. Think of it like this. What we've created here is a gigantic cookie cutter. Okay? The little box is the cookie cutter. The walls are the cookie. Okay? And we're going to go shoom. Okay? We're going to make a square size opening in our cookie dough. So we always select the cookie dough first, the cookie cutter second. Okay? And with that selection order completed, here it is, the Boolean operator. Okay? This is the magical tool that's going to do the hard work for us. Let's do it real fast. Let's fire off Boolean. Now on the surface, you're like, Pat, mission failure. That does not look at all what I was thinking it was going to look like. You told me that there was going to be a hole. And you're right, right? However, let's continue to examine the tool properties. There's actually 3 different Boolean operators that we can use. We have the union, which is going to glue everything together. Okay? It's going to marry all these objects together and create a whole bunch of n-gons for us. Okay? In addition, I'm just going to notice that I have the operator selected. I'm going to drag to the right. Difference. Aha! Difference is going to subtract. Okay? Think of it like this. Union is going to add the objects together. Difference is going to subtract them. Okay? There's actually a third one in here too. This is intersect. Intersect is kind of an interesting one. It's only going to leave where those two things touched. Okay? Where those two objects intersected, that's what's going to remain. Okay? So I want to, before I drop the tool, I'm going to go in and change it back to difference. Hit the Q key to drop the tool, and then voila, there's my window. I'm using a piece of geometry to cut a hole in another piece of geometry, which is pretty neat. So with this idea in mind, I can continue flushing out maybe all the windows and doors really quickly with this Boolean system. I was smart. I kept a blank line around just to ensure that I always had a window. And let's do this. I'm going to go back in time a couple steps. And I'm going to do some planning first. Maybe I want to have, I don't know, 3 of these. So maybe like a duplicate with special would be more appropriate. I want to have 3 windows evenly distributed along this front wall. I want a lot of light in Pat's modeling shack. Okay? Natural light's always a good thing. Edit, duplicate with special. Let's look at the options. And I think I want to have 3. Oops. And we'll do group under, world. Hold on a sec. I don't want to duplicate the input graph. And I want to copy. I don't want to rotate them. I do want to translate them along what? The x-axis. And I don't know what. Let's just test it out. Let's do 20 or 10. Ooh, 10's too much. Way too much. Let's put it at 3. We're getting there. 4. Oops. You can see where I'm going though. Let's put this at 6. 6 is not, there's too many. Okay, I'm spending way too much time figuring this out. There we go. Shoot, I could even take these guys, Command D to duplicate them, move them over here to this wall on the back. Cut in those windows, right? This time I'm going to grab 2 of them. Command D to duplicate them. I'll rotate them 90 degrees. Oops. Yeah. You know, that totally works, by the way. This is called a double transform. If you look carefully, I got both of those windows selected. And when I tried to rotate them, that's what I got. I kind of want to rotate them together as a group instead of just, individually. Since I have both of them selected, they're both adopting and receiving the transformations of the tool. It's called double transform, right? So let's group them. And now I can edit the group. I know the pivot point's kind of wacky, but that's okay. I can always change it if I'd like. FYI, some of you guys stumbled upon this. This little icon in our poly modeling shelf is the center duplicate or center pivot point button. Boink. There we go. Now it's right there in the center. Turn off that mode by hitting the D key again. And now with the group selected, and I want to make sure that just the group is selected and I don't have the children of that group, I can rotate it. There we go. And position it where I want it to go. Now the trick with the Booleans, okay, is that they have to be going through the wall. All right. All right, I'm going to combine all of these real fast, keeping one. I always like to have one hanging around just in case. Just in case I need an extra window or an extra door. Let's combine them. Of course, delete the history. And now I can start cutting some holes in my wall, right? So I want to keep the walls, but I want to punch holes in them. Which one of these 2 objects do I initially need to select first? The walls. We always select the thing we want to keep first, okay? So if I select the walls, boop, hold down the Shift key, grab the other group, and now I can run the Boolean. I want to change my operation to difference. Voila! Hit the Q key to drop the tool, and I'm also going to take this as an opportunity to delete the history. And now I have a whole bunch of windows that are uniform in size. I know beyond any reasonable doubt that every single one of those windows is identical. Okay? Makes it easy, right? However, the big challenge that Booleans present us is with some really sloppy geometry, right? It produces a lot of n-gons. Now, n-gons aren't necessarily the worst thing to have inside of your scene. These little edges are automatically created for us, and I apologize, it's hard to see, I know. But these little edges, they're automatically created for us, so keep them in there, right? There has to be some sort of edge that connects the boundaries of the window to the boundaries of our mesh to create that surface. So if you were to delete that, it could cause some problems, right? If I was modeling this, I would try to go in after I slice in all those windows and really ensure that all of those n-gons are resolved by slicing up the mesh with multi-cut and try to get into quad polygons as fast as I can. That's just me, though. You don't have to do that with this assignment. If a surface is flat, an n-gon's fine, right? It's going to render correctly. It's going to work the way it should. I'd keep going. All right. So there's the walls. I got some windows in there. I do the exact same thing with the doors, but I'm ready to start rocking and rolling here. Next part, roof, right? Let's paint with a broad brush stroke. How are we going to create a roof? What basic, simple shape is a roof?
Pyramid?
Yeah, it's kind of a pyramid. I like it. Whenever I'm trying to figure out the basic, simple shape or how these things are put together, I try to put myself in the mindset of a craftsperson that was actually responsible for making this, right? When I was in college, in y'all's shoes, I actually spent a summer as a roofer. It was like the worst 3 months of my life. I realized pretty quickly that I was not a roofer. I was not put on this planet to be a roofer. That's hard labor. I didn't like it at all. It's very hot, very sticky. The tar that you have to use is not fun. It was just generally an unenjoyable experience. Made worse by Sacramento heat, right? Golly, have a 110-degree day, and then you have to go up on someone's roof and take out a blowtorch to melt the tar for zero-pitch roofs. That was a rough summer. But I recognized pretty quickly the nuanced creation of a roof and what it takes to go into making it, right? So I like to take that little bit of information and apply it. If I was making a roof, what materials would I have at my disposal? Would I have a whole bunch of flat boards, right? A roof is really nothing more than a whole bunch of 2x6s and some plywood, okay? That's it. There's not a lot going on in your roof, believe it or not, right? What keeps the rain out is plywood. There's some weatherproof or waterproof vapor sealing and then they got the shingles. I mean, there's not a lot on top of your roof. It looks more complex than it is. That's it. It's pretty simple and basic. Point being, it's square. A roof is basically made out of a whole series of flat objects, right? So that may be a good place for us to start. I'm going to look at my scene from the front real fast and start, in my mind, on a new cube, figuring out what this is going to look like, okay? So our roofs are pretty big. I don't know what the angle is going to be yet. They're a whole lot thinner than people kind of give it credit for. Let's see, I'm going to have this, I don't know, there is actual math that goes into figuring out like the angle of your roof, the rise and run and all of that. It's pretty complex, or can be complex. Excuse me for a moment. There we go. I'm just going to snap it to some 15-degree increments. That's a good place to begin. All right, so we'll look at this from the front. And what I'm trying to figure out here is where the roof line is going to go, okay? The roof line of our house is the peak of our house, right? It's kind of the spine of our entire home or our entire building, okay? It's an important part of the kind of the look and the feel, the aesthetic of a house. So we need to make sure it's well defined, and we can create it quickly with our tool set. All right, so at this point, the grid now becomes a really good player in this. I am looking right down the center of my little square here, okay? And shoot, just to make it easier, I'm going to do this. I'm going to grab that polygon. I'm on a new object, by the way, and I'm going to inverse my selection and then delete everything else. And what that leaves me with is just a single polygon. Working with a flat two-dimensional shape is a whole lot easier than working on a three-dimensional shape, because we can always easily extrude a two-dimensional shape into a three-dimensional shape with our extrude tool. So why make it more difficult than it needs to be? All right, so this is looking pretty good. I like its placement up and down. I'm going to use the origin of my grid to define the center line of my house, okay? I'm feeling it. This is starting to look pretty great. I'm going to turn on my grid snapping tools, okay? Grid snap can temporarily be enabled by hitting the X key, right? Or we can just turn it on, and then every tool will reference the grid in the background, which is what I'm about to do. This is our grid snap right here. And now, check it out. Now all of our tools want to snap, which is what I'm going to do. I'm going to snap and slice it that way, okay? And now I know beyond any reasonable doubt that that polygon on that side, and more specifically, this edge right there, is perfectly aligned to the center of the house, which is centered at the origin of the scene, thanks to good old grid snap. This is chaff. I don't need that anymore, because I want to mirror this shape here in a second. Now, so I've defined the location of my ridgeline here, but now I need to define the eaves of my house, okay? And there are a number of different ways that we can do this, but right now, the eaves of my house is way out over here, right? It's way too big. How far should that overhang on a house be? Yeah, it's not too much, right? It's really only about like this much. It's only maybe a foot or two. This is definitely way too big. I need it to be kind of like right here. I want that edge to be right here. How can I do that? Just slide it, move it. Watch what happens when you move it. I spent some time trying to figure out the angle of my roof and get it precisely where I wanted it. So if I went and just grabbed that edge, excuse me, and just moved it, the moment I move it, it changes the angle of my roof, the pitch of my roof, which I already have kind of established. So that's not going to work. What I really would like to do is get the tool handles to be oriented a little bit differently. I want the tool handles, the placement of the tool handles to match the pitch of the roof that I'm working on. Does anyone remember how to do this? We've actually talked about this before. The cool thing about all of our tools inside of Maya is that they have tool properties, and at times these tool properties are hidden. When we're using our modeling toolkit, a lot of these tools over here pop up that little HUD that we've been working with, right? All of this stuff down here at the bottom, though, tends to go unnoticed for the most part. And I'd like to draw your attention to these move settings, okay? They've exposed some very important tool properties here that will allow us to make some changes quickly to how we're working with this tool. Specifically, default settings are on Object. But check it out. We have a whole series of other options here that will determine and change how our tool handles are placed on the mesh itself. So what if, let's just do this. Let's see here. What if we did component? Oh, yeah. Now it's looked at the angle of the selected component inside of our three-dimensional scene and has oriented the tool handles to match that specific selection, which is kind of cool. And now, oops, looks like they're rotated a little bit. Oh, it's not perfect. Yeah, it's, now that I look a little bit more carefully at it, it's not perfect. I was like, why is it changing the roof? Because it's not aligned, that top part. It's aligned, it's close, but it's not working the way I want it to. So let's change it a little bit. Instead of using component, let's do, let's see, normal is not going to work. We don't want to edit the pivot, excuse me. Let's go back to object. And if we do custom, yeah, what is it? You can, let's see. Oh, you know what? Let's go back into our tool properties because I feel as though, yeah. So I'm going to change my axis orientation back to object, and this transform constraint. Okay, because right now the transform constraint is off. But if we do edge, here we go. Now, hold on a sec. Why is it not working? My brain is having, my brain is having a tough moment today, and I apologize. At the end of the day, it's getting soft. So the transform constraint is on edge, okay? And I think if you just simply click on the edge that you want to transform it to, it slides it up, which is going to get us where we're after. That's generally what I was looking for, but it's not actually. It's close. It's close enough for government work. I'm happy with it. Okay. So point being, larger point being, definitely look at your tool properties. They're going to help. Okay. And I always reset the tool after some time. Yeah, this is what I was looking for. This is Maya, just driving me absolutely crazy. It's this thing, because we can go in and customize the angle of our tool handles, and you set to edge. There you go. Now it should, well, no. All right, well, it's not going to work for me today, and that's okay. All right, let's reset the tool and get back to work because we have other fish that we need to fry. So that's looking pretty good. I'm happy with that, right? That's the general roof line for my house complete. Now, let's just delete the history. How do I get the other side automatically created for me? Just mirror it, right? The direction, we're going to do plus, hit the Q key, voila. All right. These are all one contiguous piece. Let's delete the history on that object. And now I can start extruding it where I want it to go. Simple extrusion on this one. It's gone black. What does that blackness mean? Yeah, the normals are not right. So let's select it, mesh display, reverse, fix the problem. Dun, da, da, da. And now we're talking. Now I got some big time problems on my house. What is it? What's the biggest problem that I have in my house? He's got no doors. That's a problem. Bigger than a door. I got the best air conditioning on the face of the planet right now, right? I need the walls to match the roof line, okay? Now, I don't know the angle of that roof line. I really don't, okay? I don't care to either. What does know the angle of that roof line? How can I create walls that perfectly match the angle of my roof line? Booleans. We're going to let the existing geometry do all the work for me. I'm a simple-minded guy, so if I can get the computer to do some things for me, I'm going to do it. Let's rename this. This is roof. And I'm actually going to duplicate it, so I have a copy. I'm going to keep that copy selected and simply just hide it. Display, hide selection. Okay, so now what I'm seeing is that roof and those right there. Okay, I'm going to go to my walls, and in my polygonal selection state, just grab that top loop and simply move it up past the roof line. Okay, I want to keep my walls, but I want to slice them and have them automatically be influenced by the roof. Okay, I want to keep the walls, delete the roof. So I'm going to select the walls first, roof second. Let's run the Boolean tools. There's difference. There's intersection, which is interesting, but not what I'm after. Difference is going to give me what I'm looking for. Q key to drop the tool. Now I have the bottom part that perfectly matches the pitch of the roof. And now I just need to simply delete that top half, and I'm on my way. Let's unhide the duplicate of my roof. This is why I made a duplicate of it. And I'll combine them. There it is. All thanks to Booleans. It's working exactly the way I want it to. Okay? Booleans allow us to take existing geometry and influence other pieces of geometry, right? However, when you're using it, if it's something that you want to hang around, kind of like my roof, make sure you make a copy of it. Duplicate that object. Because the moment you run the Boolean operator, it's gonna nuke one of those meshes, right? So if you want something to hang around post-operation, make a duplicate copy of it, okay? And now things are starting to look pretty good. Things are starting to look really good, actually. It's beginning to look like a house. And my walls perfectly match the outside of my house. Okay. We're going to skip past the doors because I'm running out of time and I want to cover the windows real fast. But the doors and the windows are very similar to each other in the grand context of things. How we create them is going to be not too different. But the windows require us to maybe construct things a little bit differently, right? Windows are pretty noticeable assets on our homes, right, or on our buildings. If we were actually making a building, we would follow a process that's not, in all honesty, too dissimilar to all of this, right? We'd get some 2x4s, we'd create big stud walls, we'd cover the outside of the walls with plywood, and then we would cut holes in that plywood for the windows, right? Kind of like what we've done here. And then the window, you guys, I know maybe way too much about this, but welcome to 3D. You have to be we have to actually kind of follow the construction practices of our real world, right? a window is actually one solid piece, right? It comes from the factory as one gigantic piece, right, that now slides into that hole, okay? We have a hole, we need to create a window that slides into that hole, and then we're going to create some trim geometry that covers the opening of that hole, much like we've done, not so much here, but look at my window on my office, okay? We have metal trim that goes around the outside to hide the unfinished edge of the window, okay? Check it out. This interior part, this is the actual window itself. This is the frame of the window that holds the glass. And then this thicker piece, this is trim, okay? This is just making it look nice. It doesn't actually serve a purpose other than literally making it look nice, okay? To kind of hide those unfinished edges, maybe do some weathering and some waterproofing as well, some acoustic dampening, what have you. But we want to do the exact same thing, or we should try to create the illusion of the exact same thing, okay? So let's figure out how we could do that really quickly with the existing geometry of our little house, okay? Check it out. This is pretty neat. I want to prototype it on one, and then if I'm careful, I'm going to have a system that I then can use on all the other windows. Since they're exactly the same, let's engineer one, and then we can use our duplication system to get a whole bunch. All right, so I want to create the illusion of some sort of window itself on the interior of my little opening here, and I think what I'm going to choose to do is, let's do this. I'm going to choose to do the Insert Edge Loop tool here. Because the Insert Edge Loop tool allows us to use multiple edges, an equal multiplier so they're evenly distributed. And I think I want 2. And now when I click, see how it created 2 new edge loops, equally spaced, okay? That's pretty cool. I'm happy with that. Q key to drop the tool. And now let's look at what we can do with that. With those 2 edges in there, maybe I go back into my faces, grab that loop, okay? To create the illusion of a window frame, let's extrude it. Give a little bit of an offset. Oops, I'm sorry. Thickness. I may have gone too far. Somewhere right around there. There's the window frame. That's cool. Happy with that. Ta-da! Okay, rock and roll. Now I need to create some sort of trim that goes around the window frame. Okay. We also need to have a window. Otherwise, we'd be able to see, in the renders, you just see right into the inside of your house and it would look like an empty house. So we need to have some sort of reflective glass on the outside that kind of blocks and, kind of clouds the illusion a little bit, right? We're magicians, so we got to, practice that trick. Shoot, some people, if you wanted to do this, this is really cool, and I encourage you to infuse this level of detail. You can create like little muttons and rails, the little vertical. You can kind of see them a little bit here on this window. The big crosses. These are called muttons and rails for the windows. Okay, those are just squares. Okay, but if you make one, you then can duplicate it. Let's get the trim going because the trim is going to be a little bit more interesting, and maybe this is where the Appended Polygon or the Create Polygon tool will come in handy. Okay, because I want to create, some really interesting shapes in here. Let's see if we can use the Create Polygon tool to help us out, maybe paired with some Vertex Snapping. Let's do Create Polygon. And I'm going to hold down the V key because I know I want to have one right there. And it's snapping right there, and of course, right there. Cool, huh? I like it. Q to drop the tool, and I need to flip it around. Reverse it. There it is. Again, we're going to run the extrude just like we did earlier. And this time, instead of doing the offset inwards, we're going to do the offset outwards to create a uniform shape going around our mesh. We're getting that Z fighting, and I apologize, I hit spacebar. We're getting that Z fighting, so let's delete the polygon and see what we're left with. So that interior one and this one down here at the bottom we don't need. What I'm looking for is just that. Aha! Let's extrude it out. Boom. Now I got a pretty convincing window frames. The normals are all flipped, but we can fix that. I lost my selection. Sorry. Reverse it. Boom, there it is. can flatten these two fellers off at the exact same time. You know, really what I want is that I want to have these two bottom edges be perfectly aligned to its neighbor up here to the north. So I think I'm going to grab both of them, fire off good old move tool, and this is where our vertex snapping system again comes into play. I'm holding down the V key. I'm going to drag upwards, and I'm going to put my mouse kind of where I want it to snap to, and sometimes that helps me out. All right. Awesome. I'm liking it. There's the trim that goes around the outside of the window, and now we need to have that little rail that goes down underneath it, kind of that window sill. Okay? Well, there's a couple ways that we can do and we can create this quickly. I think really what it is, it's nothing more than a square. So maybe just a square will help. Let's look at it from the front, get some accuracy here. I like to work in 2D as much as I can, so I think I'm going to start off by just selecting that face, inversing my selection. I didn't inverse all of it. I'm sorry. I think I had more than one face selected. Let's try that again. Select, inverse, control backspace. Yep, now I just have a two-dimensional square that I can begin to work with. Okay. So first things first, let's start getting it centered into that window. And let's see if there's a way I can make this a little bit easier for y'all to see. I'm going to get my walls. I'm just going to hide my mesh. Control H to hide it. There we go. Because now I can see the frame and the bottom of the sill. Okay. So let's do this. Let's get this kind of working the way I want. The Vertex Snap tools are really going to be my savior. I've hit the D key. And I'm going to start aligning it. Okay. And I just messed it up on accident. There we go. D key once again. And I need to stretch this polygon from right there all the way to the outside edge over there. So let's use our vertex snapping engine. There it is. Snap it up. And now, instead of doing it on the object, I'm going to do it at the component. Exact same thing. Hold down the V key, snap it so it goes there, and I'm on my way. Let's figure out the dimensions of this. The sill is actually a little bit thicker than the outside trim, and I apologize, and it's wider. Since I know that the outside edges match perfectly to the frame, I can scale from the center and knowing that the distances out here are identical. Oops, we didn't do a really great job though of pushing it back. That's okay. Hit the wrong key. Jeez. Our vertex snapping system will help us out. A simple extrusion will get us the rest of the way. Something like that. Looks like I hit undo too many times. Let's make it wider. If you look really critically at how these things are made, there's actually a small little slope on them. Does anyone know why there's a small little slope? Yeah, it's the rain. It really is. But in doing so, we have a gap between that one and that one. Let's fix that gap real fast. How am I going to do it? Just use some vertex snapping. So hold down the V key. There it is. And I snapped that bottom point. That gap's been removed and the angle is identical to the slope of its cell. Let's combine these objects. And of course, delete the history. Let's unhide our walls. Oops. I hit our windows on accident. There it is. All right. And that's starting to look pretty great. What's neat about this is that we now have an object that we can duplicate. I can very easily and very quickly duplicate this down the row. Okay? I'm not going to do duplicate with special. That's way too hard because the vertex snapping system is going to give me what I'm after. Let's just duplicate it, Command D. Fire off the move tool, and I'm just going to generally get it where I want it to go. Okay? But since I was careful, since I was ensuring that that vert right there is matched the inside edge of the window, I now have an embedded snap point. Okay? And you can do this at the object level or at the polygonal level. It's 6 to one, half a dozen to another. Let's get it all kind of aligned here. Hit the D key. Vertex snap it up. I'm too close. Just want to make sure that I'm where I want it to be. Yep. And we'll get it going right there. Cool. Oops, didn't go far back enough. That's okay. I can fix it. Hold the V key again. There it is. Now it's snapped back to that corner. Hit the D key to get out of that edit pivot mode, and now we're just doing a vertex snap right there. And I have a window in the exact same placement as the other. Our snap system really is an important part of our workflow. Okay, it allows us to work accurately and quickly, which is ultimately what we're after. We don't want to spend a lot of time making each one of these custom, right? If we can make one and then duplicate and then move that duplicate to a very specific location, that's good practice for us. So look for ways to add and include that snapping system. I think if just by looking at how I've been working here, you can see that that D key to enter into that edit pivot mode, and then X and V, I mean, that's like my go-tos, right? That allows me to work quickly and accurately and know that all of this stuff is going to be lining up the way I want it to be lined up. All right. Yeah, that's looking pretty convincing. Now, we're also going to need to have some sort of window, right? Might be good, a window. There's a couple ways that you can go about doing that pretty fast, okay? At the moment, these are just openings. If I was to throw in, I'm going to go into my rendering shelf. We're going to talk a lot about lighting next week for our house, like a lot. But for today, this is called the directional light. Okay, the directional light simulates the sun pretty quickly. I'm going to throw in a directional light. It's at the origin of the scene. I'm going to move it just so I can get a good sense of its angle. All right. I'm also going to create a floor with another polyplane, a ground. There we go. And let's see how this is working inside of our render. Oh, Arnold isn't on mine either, but let's just use Renderman for the time being. Yeah, so this is the problem that we're running into right now, okay? You can just see onto the inside of the house. That's not good, right? We want to have some sort of windows there that we can add a reflective material to have it bounce, right? So it kind of stops the audience from seeing onto the inside, okay? So how are we going to do that? Because I want to have these windows be in the exact same location in the center of the window down over here. Well, maybe what we do, oh, and I apologize, I forgot. I made an object for the window trim, but I forgot to extract those center polygons. Let's just do it real fast. Shift period expands your selection radially by one row. And I need to now extract those polygons from this object and put it on its own object, right? You can find that option way down here in your faces command, extract. It allows us to kind of like cut those polygons, okay? Extract it. It's in its own object now. There we go. And I'm going to grab that one and that one. Oops. That guy. There we go. I'll combine those. Delete the history. And now I have a singular piece, right? That's pretty cool. Okay, so on my window, this is a great trick. Great trick. Okay. Just use multi-cut. Hold down the shift key. Sometimes it's hard to get a good read if it's actually putting it in the center. It should be, yeah, there it is. It snaps to the center. Boop, just cut it in. And really what I was trying to gain here are verts right there. Oops. I want verts that I can snap to on that object. Okay. Let's rename that object in my outliner. This is the window Window frame. Okay. Because now I'm just going back to create polygon, and I'm going to ensure that my vertex, I'm holding down the V key as I snap. There it is. There's 1. There's 2. 3. And of course, 4. Hit the Q key. I'll select the polygon and reverse it. And now I have a window. Yeah, awesome. Trying to figure out why it's not letting me combine it. It should let me combine it. There we go. Yeah, and now I have an object that I can duplicate and then vertex snap to all the other windows inside of my scene pretty quickly.
You removed the name.
I removed the name. Oh, that's okay. I can always go back and rename it again. That's no problem. It's all about working smart, not hard, right? So let's duplicate that thing and get all of this. Oops. I'll have to do it at the object level. Well, I could do it at the component level. I just got to make sure I'm very careful in selecting everything. I want it to all move as one piece. There we go. Huzzah. Now that I've moved the pivot point, oops, excuse me. Forgot to hit the D key. That's my bad. Now I can vertex snap it into position, and it matches just absolutely how I want it to match. If we go back to our render, yeah, that's really what it should look like. Because then those interior polygons, these, I'll just apply a transparent material, or it doesn't even have to be transparent. It just needs to be kind of reflective, so it looks like glass, right? Imagine it like a tinted window.
How did you get it to be solid again?
Yeah, so I just used that center line in my frame as a snapping point for the Create Polygon tool. Because, yeah, for the Create Polygon tool. And that ensured that it just fit just absolutely perfectly inside that square. One of the things that I would like you to do as you start the process of creating your little house is do some reference research. Is to really critically look and examine how these houses are put together and start understanding the physical properties of a house. There's a lot of stuff on there. What does that look like? What are the size, scale, and proportions of this? How big are the windows? Everyone thinks they knows what a house looks like, but then when I ask you to make one, it's a different story, right? We want our objects, all of them, to be founded in reality as much as we can. So I have the world's easiest lab assignment, in addition to the Lego brick. If you return to the week 8 section on Canvas, I want you to do some research, okay? I want you to just look at some pictures of houses and start collecting pictures of houses. The pictures that you collect can be of any house. They don't have to be the house that you're going to make, right? I just want you to start getting into the mindset of how these parts and pieces are put together to create the illusion of a house. Luckily for us, the architectural world, it's pretty simple construction practices for the most part. Unless you're like the Guggenheim or something, you know, or like the Walt Disney Theater down in Los Angeles that's looks like a wave or something. That's for the most part, things are pretty angular, which makes it easy for us. But start looking at some pictures. I want you to collect some reference. There's no expectation on my side or by your side that you should build the reference that you collect. However, I think it's an excellent idea. Okay? You can also take your own reference photographs. So if you want to build your own house, go out and take 10 pictures of your house. Okay? If you want to make the technology building, which is not a great thing to make because it's a gigantic rectangle. Or maybe it's the easiest thing to make. I don't know. Take some pictures. I want 10 reference photographs. Okay. Also, as you go through this process of collecting reference, pay real close attention to scale. Look critically at the pictures and say, what can I see in the pictures? How much detail do I need to model in order for this picture that I'm going to make with my own 3D tools to make it look real? A great example of this is doorknobs. From a distance, what basic shape is a doorknob? But what basic shape is it? It's a sphere, right? Most doorknobs are spheres with a cylinder coming out the back, right? Or, if you have the little flappy paddle ones, right? That's just a real quick square with a cylinder popping out the back. You're never going to get close enough to that part of the model to really appreciate a high resolution amount of detail. I had a student, this was years ago now, they made the most wonderful door, right? It was very clear that they spent like 20 hours on the door of this house, and it looked fantastic, right? There was all this wonderful detail, and it looked great. But then when it came time to take a picture of it, to make a render of their house, of course, you're going to be pretty far away, okay, to fit the entire house in to the render camera itself. Let's just turn on our resolution gate here. This is for Pat's modeling shack. This is about what the composition's going to be, okay, for our render. At the composition of this student's render, you didn't see any of that detail. They must have put 2 million polygons on that doorknob, and you never saw any of it. You never saw any of that hard work. Point being, be aware of the distance of the render camera to your house and model to that distance, okay? As all things with 3D, if you don't see it in the render, you don't see it in the render, right? This is not a video game where they can cruise around the model and get as close as they want to the objects themselves. We're creating photographs, so we need to be mindful of what resolution that photograph is capturing. Make sense? Start basic, okay? And then add layers on top of that. Think through this logically as well. And sequentially, just how I've done here. What's the floor plan going to look like? How big are the windows going to be? What's the roof line going to look like? How can I start integrating all these different assets together with some trim and some details that will suspend disbelief and create a whole series of compelling renders? Okay? Good house models have a good amount of detail in them, but if you're modeling every single roof tile, well, if you're modeling every single roof tile, I say go for it, man. That's awesome. If you can do that, thumbs up for rock and roll, man. That's awesome, right? I've done that from time to time. It's a tremendous amount of fun. It's a brain scratcher to get everything to work correct, but you can do it, right? But if you don't see the benefit of doing that, okay, in the actual render, you just wasted a lot of time, okay? So be good stewards of your time. Don't model something that you're never, ever going to see in the final picture, okay? Make sense? Yeah? Everyone looks terrified right now. A little bit? Yeah, a little bit. As I mentioned before, this is going to be a two-part assignment. Model this week, lighting and textures next week, okay? We're going to have a big conversation about lighting and textures next week, so if you want to put some simple materials just to kind of start colorizing things, I'm cool with that. But don't spend a lot of time going in and tiling textures on everything and adding lights. We're going to have a dedicated time for that next week, okay? Questions, comments, major concerns? Yes, sir.
So you're talking, are we going to talk more about getting pictures, or how do we upload them?
Yeah, so you're uploading 10 pictures to Canvas, right? What I would recommend, the easiest way to do it, is put them all in a folder, zip up the folder, poof, upload them all at once. I just wanted you to start thinking about houses, and the reference photographs are going to get you in that mindset. We need to see before we build, okay? Questions, comments, concerns? All right, we got about 15 minutes left in class. I'll let you guys use this time wisely, okay? Let me stop the live stream. I'll come give you guys a hand.